thought for the day. जो सुख को चाहे सदा सरन राम की ले, कहो नानक सुन रे मना दुर्लभ मानुख दे. अर्थात, if you yearn for the eternal peace, then seek the sanctuary of the Lord. Says Nanak, listen, mind, this body is difficult to obtain. Unit 2 Solutions Part 4 Osmotic Pressure. Osmosis and osmotic pressure. Dear student, before studying the osmotic pressure, we should study osmosis. What is osmosis? Let us understand this with the help of an animation. I have an beaker and I am introducing a solvent, maybe the water in this beaker. And you are seeing the water is filling and semi-permeable membrane and solvent is shown, and this instrument in red color having a solution, higher concentrated solution. And when this higher concentrated solution comes in contact with the solvent, then there is a flow of solvent into solution, and this flow of solvent toward solution is known as osmosis. In other word, you can say osmosis involves the flow of solvent from lower concentration to higher concentration, as shown in the movement of solvent molecule from lower concentration to higher concentration through a semi-permeable membrane is known as osmosis. Okay, this is the osmosis. Now, some example of osmosis are raw mangoes shrivel when pickled in brine salt water. Wilted flowers revive when placed in fresh water. Blood cells collapse when suspended in saline water. Dry vegetable and fruits becomes fresh when placed in water. Water movement from the soil into the plant roots and subsequently into the upper portion of the plant is partly due to the osmosis. Osmotic pressure. Now, what is osmotic pressure? The pressure that just stop the flow of solvent through semi-permeable membrane is called osmotic pressure of the solution. The exact pressure shown, if I don't apply the pressure, then the solvent will go up to height H. But if P is shown, if I apply just pressure from the upper side to stop the entry of the solvent molecule through semi-permeable membrane into solution, then this pressure will be known as osmotic pressure. It is the minimum. Other definition of osmotic pressure is it is the minimum pressure, excess pressure applied on the solution to stop the osmosis. Third definition is also there. The osmotic pressure of a solution is the excess pressure that must be applied to a solution to prevent osmosis. That is, to stop the passage of solvent molecule through a semi-permeable membrane into solution. It is all about the osmosis and osmotic pressure. Now, reverse osmosis and water purification. What is the reverse osmosis? I am just explaining this with the help of this animation, and we have two solutions, two solvents separate. One is solvent and other is solution. These two are separated by a semi-permeable membrane. In first beaker, I am filling pure solvent. It is solvent or lower concentrated solution. In second beaker, there is filling of solution. You are seeing solution is filling in the second beaker, and semi-permeable membrane is also shown here. There are two beakers and separated by a semi-permeable membrane as shown. And now solution solvent is already red. In red it is solution, it is in pink it is solvent, and all these are separated by semi-permeable membrane. Pressure, if P is greater than osmotic pressure, then P is greater than osmotic pressure, then as shown in the diagram, there is flow of solvent molecule. Solvent molecule are flowing from the higher concentration, that is from solution side to solvent side. This is known as reverse osmosis as shown by this animation. Again, solvent molecule are moving from solution to solvent. Reverse osmosis is used in the desalination of seawater as shown below. We have this diagram, and there is salt water in blue color, salt water, and there is a piston, and if we apply P is greater than the osmotic pressure, then reverse osmosis take place and there is flow of solvent from solution side to solvent side, and the solvent moves out and ions remains behind. NaCl remains behind. And note one, pressure required for the reverse osmosis is quite high. Note two, a workable porous membrane is a film of cellulose acetate placed over a suitable spot. Cellulose acetate is permeable to water but impermeable to impurities and ions present in seawater. For dilute solution, it has been found experimentally that osmotic pressure is proportional to the molarity C of the solution at a given temperature T. Therefore, pi will be equal to CRT, or I am putting the value of C. C is equal to NB upon V. NB is number of mole of solute and V is the volume of solution in liters. Therefore, pi will be equal to NBRT V divided by V, volume of the solution in liter, or pi V will be equal to NBRT. And osmotic pressure is a colligative property as it depends upon the number of solute particles and not their identity. Therefore, in equation it is clear pi that will be equal to r t. R is constant, t is constant, v is also constant. Therefore, pi directly depend upon number of solute particle. Remember, by convention we use for solute either b or 2, for solvent either a or 1. Calculation of molecular mass of solute, and this can be calculated as we know pi is equal to n2rt upon v, but nb or n2 is equal to w2 upon n2. We are putting the value of n2, w2 upon m2, r into t, pi as shown equation. M2 can be easily calculated. Molar mass of solute can be easily calculated by the application of osmotic pressure. Note number one, semi-permeable membrane of parchment or cellophane which allows only solvent molecule to pass through it. Therefore, SPM shortly represented is the membrane of parchment or cellophane. And osmosis increase with the increase of temperature. And note number three, osmotic pressure measurement are preferred over other methods. This is very important question because number one, osmotic pressure measurement are at room temperature and the molarity of solution is used instead of molality. Number two, as compared to other colligative properties, magnitude is large even for very dilute solutions. And number three, it is useful for determination of molar mass of the biomolecules as they are generally not stable at higher temperature and polymer have poor solubility. These are three reasons due to which osmotic pressure measurements are preferred over other methods. Isotonic solutions, hypotonic solution. Two solutions having same osmotic pressure at a given temperature are called isotonic solution. When such solutions are separated by a semi-permeable membrane, no osmosis occurs between them. For example, the osmotic pressure associated with the fluid inside the blood cell is equivalent to that of 0.9% mass by volume sodium chloride solution called normal saline solution, and it is safe to inject intravenously. And on the other hand, if we place the cell in a solution contain less than 0.9 sodium chloride, water will flow in cells and they would burst. Such a solution is called hypotonic solution. And if salt concentration is more than 0.9%, the solution is said to be hypertonic. As shown by this diagram, this animation, I have this NaCl solution, 0.9% NaCl solution by mass over volume. And here is blood cell, and blood cell is shown semi-permeable membrane and blood cell. If these are isotonic solution, there will be no osmosis, no flow of solvent from NaCl, either from blood cell. There will be no flow of the solvent from either side. If concentration, this NaCl concentration is lesser than 0.9%, then what will happen? There will be the flow of flow of solvent from saline solution to blood cell, and they will swell and they may burst. Thank you for attending the lecture.